The sharp mirrors of the James Webb Space Telescope will finally be able to probe into the atmospheres of sub-Neptunes, which are mysterious planets that aren't found anywhere near Earth. The observatory is in the middle of a commissioning period that will last until about June. But when it is ready, the observatory will seek out sub-Neptunes that are close to their parent stars to assess more about the fundamental nature of these large planets, NASA said. Although classified as planets that are bigger than Earth but smaller than Neptune, sub-Neptunes remain mysterious by many metrics despite the discovery of hundreds of these worlds, NASA said in a statement late in 2021. Are they dense, Earth-like balls of rock and iron, blanketed in thick layers of hydrogen and helium gas? Or less dense mixtures of rock and ice, surrounded by steamy, water-rich atmospheres? NASA asked. With limited data and no planets of similar size and orbit in our own solar system to use for comparison, it has been difficult to answer these questions. Answering these questions will require a deep dive into the sub-Neptune's atmospheres, using a technique called transmission spectroscopy. Webb will watch each planet as the world passes across the face of its respective parent star. Some of the wavelengths or colors of starlight will be filtered out due to gases in the planet's atmosphere, allowing scientists to look for a distinctive signature for different elements. Unfortunately, aerosols, tiny particles or droplets, that tend to congregate in sub-Neptunian atmospheres do obscure the view. Such aerosols will scatter starlight and make the signatures almost impossible to interpret with most observatories. Webb, however, has an advantage as it is located in a deep spot in space far from interfering light, and comes equipped with a large mirror to render sharp images of distant objects. An observation program aims to look at two sub-Neptune-sized planets in Webb's first year of observations, GJ1214b, which you can think of as the original sub-Neptune due to its early discovery announcement back in 2009, and the much more recently found TOI 421b, announced in 2020. GJ1214b orbits a red dwarf star relatively nearly Earth, and has already been featured in dozens of studies. Other advantages of looking at this planet include its short orbital period, making many transits possible in a short time, and the planet's large size relative to its star, which allows great observations of its atmosphere. The team plans to use Webb's mid-infrared instrument, MIRI, to look at the planet for 50 hours straight, capturing a little more than one orbit of the exoplanet. Scientists will use transmission spectroscopy to look for water, methane, or ammonia. Thermal emissions, visible in mid-infrared light in which Webb is sensitive, should provide information about the planet's temperature and reflectivity. Along with these observations, the research team plans to use Webb's ability to sense very small changes in how much light the system emits while the planet orbits the star. The curve or brightness graph of these changes will allow an approximate map of the average planetary temperature by longitude. This map will in turn allow astrophysicists to better model the planet's atmosphere composition and circulation. TOI 421b will be examined to see how similar it might be to Titan, a Saturnian moon famous for its smog-like, organic-filled haze. Webb will look at the TOI 421b during two occasions, observing transits using its near-infrared imager and slitless spectrograph, NIRIS, and its near-infrared spectrograph, NIR-SPEC. The two instruments working together should provide an excellent transmission spectrum of the planet. The suspicion right now is TOI 421b has much clearer skies than Titan. If that is indeed the case, the spectrum should easily show the components of water, methane, and carbon dioxide. If aerosols are scattering light, Webb is likely to still gather enough data to show off what the aerosols are made of. The studies will be co-led by Eliza Kempton of the University of Maryland, College Park, who specializes in theoretical modeling of exoplanet atmospheres, and Jacob Bean, an astronomer at the University of Chicago who has led many other exoplanet studies.